Hello everyone, welcome to another Game Without an Engine devlog video. So today we're covering day 111. We worked on more of the texture viewer. So we specifically added the ability to actually view some textures and pan around and zoom in and actually view some of the properties in the texture as well. So before I pass you on to Future Henry, what I want to cover is that the streams are streamed live on Twitch. There is a timetable there if you want to see more specifics. But also, if you want to support via Twitch or Ko-Fi, you get source code access, and thank you to everyone who's already doing that. Big help, thank you. It runs on Windows and Linux, so you've got some two OSs there. And if you can't catch the live streams, but you see in this devlog that there's something interesting that you want to see more into, you can check out the VOD channel on YouTube. It's right there, and there's also Discord where you can come and hang out and chat off stream and all of that. Right, so we just got the left-hand panel done. So if we build up the texture viewer and click on a texture, we'll see that there's this left-hand panel, and it's now got like the name of the texture, the two different formats. One's the sample format, one's the storage texture format, and it's got the dimensions of the texture as well, along with the MIP levels and array layers. And these two are input boxes for when we want to view a specific MIP level or array layer. So now we have all the information and the viewing options that we need at minimum to start viewing the texture, right? And notice when we put some values in here, it clamps it so it doesn't go out of bounds. So let's take a look at the code. We've effectively, we've got if we've got a texture to view, we have this split area. We've got this is the left-hand side box of the split area. And we get the resource that we're viewing. And essentially we just keep taking from the top. Here's the button. Here's the name, format, dims, MIPs, and array layers. We just use a bunch of text widgets and snprintf into a temporary buffer. And then we have a box for the separator for the options, and we then put in the MIP level viewing options and the array layer viewing option as well, which is just a input box. I don't have combo boxes, so we're just using input boxes for now, and they'll probably be fine. And we just clamp the value here so that they don't go out of bounds. So there's still some missing things from here, like the hover pixel and reinterpreting pixels, but these things are nice things to add when we have when we're actually able to view the texture. So that's what we're going to work on next. Right, so we've gone ahead and made a new texture resource, and we're going to be copying the textures that we want to view into this separate texture resource. So it's got the size of the maximum size of a texture can be. So it can fit any texture in there, and it'll only be around for debug purposes, so we don't have to ship with this. But essentially we want to view a texture, but only like a certain MIP level or a certain slice, and we want to reinterpret the pixels and view them differently. So we're going to be taking the texture from a certain point in time in the frame, copying it to this texture. And then while we're doing the copy, we'll be changing it to a certain RGB color that that's reinterpreted the pixels into something sensible and easier to view if that option is enabled. So something else that's obviously popped up is in the texture viewer, we don't want to be able to view this texture. It makes no sense. So obviously when we filter out the texture IDs, that we want that are controlled by this filter text box. We also include in this loop, when we iterate over all the resources, if the resource is this texture viewer copy, then we're just going to skip those. So now that we have this texture resource copy, we're going to go ahead and actually copy our first texture into this resource. Okay, so what we've gone and done is moved this resource type from CPU code to code that's accessible from the GPU and CPU. So we moved it from this gpu.h into gpu.shared. So now on the GPU we can know if a resource is a texture 2D, 2D array, or a 3D, which is helpful for our texture viewer copy shader. And it's just a compute shader which launches across the whole of the source texture we want to copy from. So when we are trying to read it from a certain point in time on the frame, we inject this shader, or we're going to inject this shader, and it's going to copy it at that point in time and put it into the texture viewer copy. So it's got a few parameters in the push constants, like the texture it wants to read from, the resource type, the number of MIP levels, array layers, the dimensions, the MIP level, and the array layer. So we do some basic safety checks just in case if we go out of bounds on the texture by the 2D coordinate, the MIP, or the layer. We're going to just return so we don't crash. And then we check the resource type. If we're a texture 2D, we load from that pixel coordinate as a texture 2D. If we're a 2D array, we make a coordinate out of the X, Y, and the layer parameter which is passed in. And we load from the texture 2D array. And then 3D is the same thing as the 2D array, but we do the 3D load instead. And the 3D coordinate comes from the layer. So we're going to leverage the array layer for 3D textures, so we can see through all the different layers that way. Then after we get that pixel, we're going to unpack the pixel as some color. We're going to reinterpret the pixels potentially based on our viewing options, so we still need to do that still. Then we pack the color back and we store it into the destination texture. So now the user interface can literally just display this texture viewer copy, and it should be, and it's just relatively straightforward to do that, which would be nice. Yeah, so let's go ahead and get this shader plugged in and get it copying something. Alright, so what we're going to do is we made this GPU texture viewer dispatch copy. So it's going to dispatch that compute shader we saw earlier from the CPU side. So what it is, we clear the whole texture since there's going to be some parts of it which are going to be uninitialized, or from previous copies. And then we get the currently selected tab, and if there's no resource, we just return. Or no selected resource for this tab, we just return. And then we get the currently selected resource. We initialize all these parameters we saw earlier, like the resource index, the text, the resource type, the MIP levels, the dimensions, the currently selected MIP we want to view, and the array layer that we want to view. Then based on the resource type, we fill in the array layers a bit differently. So 3D uses the dims.z, whereas the texture 2D and the 2D array use the array layer. And then we do some synchronization code. So we read only from the texture we want to copy from, the one we want to view, and then we read write into the texture viewer copy texture, and we dispatch the shader. So from there we had to change in the texture viewer as well, we have to probably make the color alpha fully opaque. But yeah, when we reinterpret some of these pixels, I've noticed actually when we view the depth buffer, it's just a 32-bit integer, which actually ends up being a floating point. Reinterpret costs into a floating point, 32-bit. So we kind of just overwrite the, yeah, this is just, so it just looks a bit weird, but yeah, we'll see that in just 1 second. So yeah, in the UI code, all we did is where we do that split area now. So here's the left-hand side box. After that, with all the attributes and stuff, there is a right-hand side box. We get the rectangle for that. We calculate the UV dims. So this would be from 0 to 1, where the 1 means the maximum texture size, which is the size of the copy texture, and then this is the size of the resource. So we divide the size of the resource, which is always going to be smaller than or equal to the maximum texture size. This will give us a nice value between 0 and 1. And we need this for when we draw the texture. And then we've also got the sort of view dimensions on how big we want it to be on the actual screen. So we've just hard coded it to be 1/4 of the size for now. Then we're saying we're going to, so we haven't used the UI image widget, we've just got into the draw API code. So we're just saying, hey, we're drawing a bounding box with the local space size being this. Well, this is the half dimensions actually. This is the reason why it's a bit weird, why it's too big. This is half dims. Okay, right. Then we say, hey, we're gonna color in this shape with a texture. So we give it the copy texture here, not the resource texture that we want to view, the copy texture. And then the clamp nearest sampler, because we want to make sure that we are seeing each pixel and it doesn't get smudged. And then we put the dims in here to say, hey, we don't want to view all the stuff that's off the edge of this texture that we've copied into that temporary, to this copy texture. And then we finish the draw command by giving it some screen space center position, and then that will draw onto the screen within the clipping bounds of this box here. So one thing I did actually forget to mention before we run is, for now, at the end of, so when we submit a frame submit, we call that dispatch copy for that texture viewer. But we obviously want to insert this directly after when the resource has been written. But for now, we just put it at the end of the frame because we know there will be something in there at least. So we give that a run, hit F9, and then we're going to view like the occlusion texture, and this is what it looks like. Again, we're seeing some floating point number with a hard-coded that's then turned into RGBA and then hard-coded alpha, so it looks a bit wrong, but at least it's the start to something. We still want to add some controls where we can sort of move this around the screen and zoom in and zoom out, but it's a nice start. So yeah. All right, so we've added the ability now to offset the texture and zoom in and out. Well, we just zoomed out, but yeah, centered around where the camera currently is. And yeah, it's got some minimum and maximum range, but this is basically a killer feature that we're going to need. But yeah, let's quickly take a look at the code, what we've done. So we've basically just added these global variables called view offset and view scale. View scale is initialized to 1, whereas view offset is initialized to 0. So we've just done it right in where we have that sort of right split panel, right where we draw the image, which we just went over earlier. And we're saying if the mouse position is within the canvas, if the mouse button is pressed, apply the relative position to the offset. And then if the mouse wheel has changed, then we get the old scale. We offset the current scale by 1/4 of the mouse wheel movement, and then we clamp it, and then we divide the view offset by the old scale and scale it by the new scale, and that helps us do this centered zoom around the center basically. So yeah, that's all pretty nice.